Now here 1 by 2 into the first term, we have to substitute d square equals to minus 25. Then it will become 1 by minus 25 minus 40 plus 3 of sine 5x. This is the first term. Plus second term, 1 by, in place of d square, we are substituting minus 1. Minus 1 minus 4d plus 3 of sine x. Sine x. Now, if we do simplification, the denominator part is going to become like is equals to 1 by 2 into 1 by minus 4d minus 22. So from that, I am taking minus common. So we'll get minus of 4d plus 22 into sine 5x. Sine 5x plus 1 by minus 1 plus 3 is 2. 2 minus 4d of sine x. But if we observe the first term and second term, looks like the first term, whatever here it is there, this is the form of type 2. And same manner, this is also in the form of type 2. But what we have to substitute in using the type 2 procedure, we have to substitute d square is equals to minus 5 square is nothing but minus 25. But we are not having any d square in the denominator. Here also, we have to substitute d square is equals to minus 1 square is minus 1. We are not having any d square in the denominator. So, because of that reason, we have to convert our problem into in the form of d squares. For getting it into d squares, what we discussed, we have to go for rationalization. We have to go for rationalization. So, how we'll do the rationalization? I am taking minus 1 to the numerator part. Minus 1 by 4d plus 22 into, we have to multiply and divide with the 4d minus 22. That is the rationalization process. 4d minus 22 multiplying and also dividing with the same. Then we'll get, okay, and this is the first term of sine x plus, sorry, sine 5x plus something of this and braces and braces going to write. Okay, so here it will be sine 5x. Same manner for the second term, we are having 1 by 2 minus 40, and we have to do rationalization. With which one we have to do rationalization? Multiply and divide with the 2 plus 40. 2 plus 40. Okay, so if we do this, then we'll get the coefficient is sine x. Sine x like this. Now, if we do the simplification process, if we do the simplification, then we are going to get 1 by 2 is common for both the terms. Minus 1 into 4d minus 22. I am writing the numerator part as 22 minus 4d by, and the denominator will be 4d whole square minus 22 whole square of sine 5x. This is the first term of sine 5x, the first term. And going to the second term, it can be written as 2 plus 4d by 2 minus 4d into 2 plus 4d can be written as 2 square minus 4d whole square. So this is only denominator part of sine x. Now, if we, okay, we have to do some more simplification, then only we can go for substitution. One more step going to write. Here, we are going to get 1 by 2 into 22d minus 4d is the numerator part, same as it is. 22 minus 4d, and the denominator will be 4d square is nothing but 16d square minus 22 whole square. So for finding this, what is a 22 whole square? 484 of sine 5x. This is the first term. Plus second term will be 2 plus 4d by 2 square is 4 minus 4 square is 16 and d whole square is d square of sine x. Now, according to our discussion, what we have to substitute here? we have to substitute here in the first term. If we observe these in the form of 1 by f of d of sine 2x type 2, and the second term is also in the form of type 2. So we have to substitute, put d square equals to minus 5 square, nothing but minus 25. D square equals to minus 25 in the first term. Same manner, we have to substitute in the second term, put d square is equals to minus 1 square is nothing but minus 1. Minus 1. Then continuing with this, then we are going to get 1 by 2 into 22 minus 4d by 16 into minus 25. I'm substituting and doing the simplification directly. 16 into 25 will be, we are going to get 400, which is minus 400. Minus 400 minus 484. Because we are substituting and calculating directly, why should we have to waste that step? Again, it means, and also space, so that it is very important for you. The space will play a very important role in your examination. 4 minus 16 into minus 1. D square is minus 1, then it will become 16 plus 16 in the denominator of sin x. Now, if we do these are the things and doing the simplification, multiplying both the terms with 1 by 2. Both the terms with 1 by 2. So 1 by 2 into, what is the denominator will get? Minus 884. And what about the numerator part is going to become 22 minus 4d of sine 5x. So multiplying 22 with sine 5x and minus 4d with sine 5x. Then we are going to get 22 sine 5x minus 4 into d of, better I'll write with a different color, then you can understand, d of sine 5x. This only first term. This only first term plus second term. Same manner, we have to multiply the second term also with 2. And what is the denominator part? 4 plus 16 is 20. And the numerator multiplying 2 plus 4d with sin x, then we'll get 2 sin x plus 4 into d of sin x. So writing it, d of sin x. So this is very important, so that I mentioned with the different color, just to remember. So now, here 884 into 2 becomes minus 1 by 1768 into 22 sine 5x minus 4 into, what is the differentiation of sine 5x? 5 into cos 5x. 5 4s are 20. I am writing that step. 20 cos 5x. This is the first term. Plus 1 by 2 into 20 is 40 into, second term is like this, 2 sin x plus 4 into differentiation of sin x. dA is nothing but d by dx of something, that is sin x. So d by dx of sin x is cos x. So this is our yp. Take it as equation number 4. So what we have to do? Substitute 3 and 4 in equation number 2, as we are taking the same process in all the problems. So substitute equations 3 and 4 in equation number 2. Then that implies y equals to yc plus yp. That implies y equals to yc is, I think, c1 e power x plus c2 e power 3x. Okay, if you find the roots for this, m is equals to 1 comma 1 will get it. I don't know whether you people did it or not. Okay, so simplifying, directly substituting here, c1 e power x plus c2 e power 3x plus yp is nothing but minus 1 by 1768 into 22 sine 5x minus 20 cos 5x plus 1 by 40 into 2 sin x plus 4 cos x, like this. So this is the general solution of given differential equation. Is general solution of given differential equation. I'll discuss one more problem, then I'll stop this model. So going to take fifth problem. In this problem, you are going to learn 2 points. One is cos cube x, how to write it, and same manner cos of 2x minus 1. So I did not discuss in the previous lecture cos ax only we discussed, or sin ax, but here it is cos ax plus b form. Even it is in the form of cos ax plus b form, you simply just treat it as cos ax only, and you can continue with it. Okay, so that's the thing. So let me finish the total problem from each and every step. So given DE is d cube plus 1 of y is equals to cos of 2x minus 1 plus cos cube x. Take it as equation number 1. And what is the general solution of equation number 1? It is a first cubic, third order linear differential equation with the constant coefficients. And it is a homogeneous or non-homogeneous? Non-homogeneous linearity. Because the right hand side part, we are having q of x function is existing. Q of x function is existing. So because of that reason, then its general solution is y equals to yc plus yp. Okay, take this as equation number 1. Sorry, 2. So finding yc. While finding yc, we have to consider auxiliary equation. Consider auxiliary equation. That auxiliary equation I am writing directly. F of m equals to 0. What is m here? Oh, sorry. What is f of d here? D cube plus 1. So f of m is m cube plus 1 is equals to 0. So if we take these are the roots. That means these are equation. Then we are going to get roots are 1. Okay. Minus 1 omega, like that we'll get it. Okay, anyhow, how we can write this one? A cube plus b cube. What's the formula of a cube plus b cube? A plus b into a square minus ab plus b square equals to 1. Then if you find the roots for this, I'm writing m is equals to minus 1. And you use your calculator or the general way, then you can find the roots. I am writing the roots directly. M is equals to 1 plus or minus root 3i by 2. So nothing but m is equals to minus 1 comma 1 by 2 plus or minus I into root 3 by 2. Now what are the roots we have here? One is real root. What about the second root is? Second and third root is? What are the second and third roots? Or complex roots or surds? Complex roots. So be careful, students. Whenever we are having I variable, forget about root 3 does not exist. A perfect value, but still I is there. So we have to assume it is as a complex root only. Forget about what is I coefficient. It may be having root or not. Okay. Then what is its complementary solution? Complementary solution YC is equals to C1 e power minus x plus what is the real part? 1 by 2. So e power ax nothing but 1 by 2x into C2 cos. For complex we'll get only trigonometric functions, not hyperbolic. Cos of root b by bx. B is root 3 by 2 of x plus C3 into sine of root 3 by 2x. Root is only for 3 but not for 2 and but not for x. Okay, so these are our complementary solution. I think we did not get till now any problem like this, so that I used this. I explained this. Now finding yp. Finding yp. What is the procedure of yp? For finding this yp, I am going to write first what is a given q of x. Given q of x is equals to, yes, anybody can remember? I think cos of 2x minus 1 plus cos cube x. Let me check. Cos of 2x minus 1 plus cos cube x. But we cannot do anything with the first term, cos of 2x minus 1. But we have to treat like this, cos of 2x minus 1 only. Don't go for cos a plus b formula. If you go for cos a plus b, cos a cos b, cos a minus b formula, cos a cos b plus sin a sin b. So b is 1, so cos 1 we cannot write anything. Sin 1, it is a constant value only, but we cannot write anything. So because of that reason we have to keep like this. And what we discussed, cos 3 theta. What is the cos 3 theta? We discussed cos 3x equals to 4 cos cube x minus 3 cos x. This one only we discussed in the last class, and you know already this formula. So I am bringing minus 3x to left hand side. What we are going to get? 4 cos cube x equals to cos 3x plus 3 cos x. And now cos cube x can be written as, I am writing directly here, 1 by 4 into cos 3x plus 3 cos x. Okay, this is our q of x. Now we have to take this, and I'm taking this as a rough work, since using this is the formulas. Okay, since by using this formula. Now going to take our yp. What is our yp? Yp is equals to 1 by f of d of q of x. That is a process. But here I am taking 1 by f of d is d cube plus 1 of q of x. That q of x I am writing as it is what we have taken here. So q of x is cos of 2x minus 1 plus, I am separating 1 by 4 for all, 1 for the next two terms, 1 by 4 into cos of 3x plus 3 by 4 into cos x. This is the thing. Now any advices, shall we do all the 3 terms at a time or shall we do separately? Choice is yours. Choice is yours.
Separately, sir.
Separately? Okay. Then as one of your friend mentioned as separately, though I'm first writing in the form of yp is equals to 1 by d cube plus 1 of d cube plus 1 of cos of 2x minus 1. Okay, I am explaining here separately because it is also a practice for you people for your future reference. 1 by 4 into 1 by d cube plus 1 of cos 3x plus 3 by 4 into 1 by d cube plus 1 of cos x. Cos x. Now, what I'm going to do is here, I'm putting brackets like this. This is the first term, okay, plus 1 by 4 into, this is the second term, plus 3 by 4 into taking this thing. Now, tell me one more important point here. It is, shall we take yp is equals to, sorry, shall we take yp is equals to yp1 plus yp2 plus yp3? Shall we take like this, or shall we take observe what I am changing with the different color? yp2, shall we take yp2 is the total one including 1 by 4 or other than 1 by 4? Choice is yours. We will include yp2 is including 1 by 4 or other than 1 by 4. You can speak. 1 by 4 include Jedama.
Other than 1 by 4, sir.
Other than 1 by 4. If we want to take like one other than 1 by 4, so we must write here it is 1 by 4, and same manner yp3 coefficient also we have to write 3 by 4. And one more important point, while we are substituting the values of yp1, yp2, yp3, please make a note, 1 by 4 and 3 by 4 you must write in equation number 4. Okay, that we will see. There may be a small mistake you people can do. That mistakes you have to avoid it. Now finding yp1. yp1 equals to, what is the yp1? 1 by d cube plus 1 of cos of 2x minus 1. Yes, according to, it is in the form of type 2. So what we have to substitute here? Put d square is equals to how much? Minus 2 square only. What I mentioned, cos x, whenever we have cos x, then we have to substitute d square equals to minus a square. Same manner, whenever we are having d square, cos of ax plus b form, then also we have to continue with the same. But here, do we have d square? No. Then what to do? We have to, I'm finding here d square is equals to minus 4. On both sides, I'm multiplying with the d. Then what I am going to get? D cube equals to, how much we'll get? Minus 4d. This is important. So second important, first point is, we in this problem cos cube x writing as like this, first point. And the second point is, whenever cos 2x minus 1 is available, then also we are substituting d square equals to minus a square only. And the third point is, we are splitting it into 3 parts, yp1, yp2, yp3, like that. And the fourth point in this problem, very important point, is d square equals to minus 4 multiplying on both sides with the d. Then we are getting d cube equals to minus 4d. Is it clear to everybody? Then I'm substituting these other things in our question. That is a 1 by, what is the d cube? Minus 4d plus 1 of cos of 2x minus 1. Now, it is in the form of, still it is in the form of type 2, but still we cannot substitute d square is equals to minus 4, because we are not having d square in the denominator. To get d square in the denominator, writing the denominator like this, 1 plus 4d. Now we have to, it is 1 minus 4d only. It is 1 minus 4d, and we have to rationalize this with rationalize. That means we have to multiply and divide with 1 plus 4d. Multiplying and dividing with 1 plus 4d of cos of 2x minus 1. Same process, but only thing is, in place of ax, we are having ax plus b or ax minus b, like that. Then numerator will be 1 plus 4d by, and the denominator will be a minus b into a plus b, a square minus b square. A square is 1 minus b square is 4d whole square. So can I, okay, let me take one more step. It's not a problem for us if we write one more step. Cos of 2x minus 1 is equals to, what's the numerator? Same, 1 plus 4d by, what's the denominator? 1 minus 4 square, nothing but 16 d square of cos of 2x minus 1. Now what we have to substitute? We have to substitute d square is equals to what we discussed in this case only, d square equals to minus 4. That we have to substitute here. Put d square equals to minus 2 square is nothing but minus 4. Because yp1 only we are finding. In that yp1, throughout yp1, d square is same only. Is equals to 1 plus 4d is the numerator part by 1 minus 16 into my d square is nothing but minus 4. So we'll do the next step is simplification and cos of 2x minus 1. So what is the denominator part? 16 fours are 64 plus 64 or minus 64, minus into minus plus 64 plus 1 is 65. So 1 by 65 is the value of total numerator writing like this. 1 multiplying with cos of 2x minus 1, cos of 2x minus 1 plus 4 into d of, this is d. Please make sure this is not 0. This is not 40. This is 4 into d of cos of 2x minus 1. Now, if we do this, then we are going to take 1 by 65 into cos of 2x minus 1, cos of 2x minus 1 plus 4 into, actually it is plus 4 into, what is the differentiation of cos ax plus b? Minus a sine of ax plus b. So that minus a, what is the value of a? 2. So what I can get directly? Can I write directly 8? I hope you people can understand. Minus 8. Now I am writing with a different color. That means you people has to understand that we are doing simplification directly. Okay, sine of 2x minus 1. So this is our which one? We got simply yp1. Now same manner we have to go for yp2 and yp3. So yp2 equals to 1 by d cube plus 1 of, yes, any of you can remember. See here, yp2, that means we are not taking this, everything is yp2. We separated 1 by 4. So that we have to take only this part. Which part? Only this part is yp2. 1 by d cube plus 1 of cos 3x. Cos 3x. Okay. So 1 by d cube plus 1 of cos 3x. Then what we have to substitute here again? What we have to substitute again here? Put d square equals to how much? Minus 3 square. Nothing but minus 9. But we are not having d square. So, but what we have? d cube. So d cube equals to what we have to substitute? Minus 9d. This we have to substitute in our function. Then it's going to become as 1 by 1 minus 9d. Okay, whenever we are having like this, then what is the next step we have to do? Rationalization. Can I do as it is as a separate step, or can I mix here? Okay, I'll write as separate step, cos of 3x. Then I'm going to do the rationalization. So 1 by 1 minus 9d is there. It is still in the form of type 2 only. It will not, once it is in the form of type 2, then it will not goes to any other type. So rationalize it, nothing but multiply and divide with 1 plus 9d of cos 3x. Cos 3x. So for the name's sake, I'll explain and doing the simplifications a little bit fast. What is the denominator will get? What is the numerator will get? 1 plus 9d. What is the denominator will get? It is in the form of a minus b into a plus b. So a square minus b square. 1 minus 81d square of cos 3x. But what we have to substitute here? It is in the form of 2. So we have to substitute here. D square is equals to minus 3 square is nothing but minus 9. So we have to substitute it in the denominator. Okay, then we'll get 1 plus 9d is the numerator by, and the denominator is 1 minus 81 into minus 9, then of cos 3x. Then if I am doing direct step here, what we are going to get? 81 9s are. So we are going to get 729. 1 by minus into minus plus 729 plus 1, 730 into multiply both the terms in the numerator, 1 plus 9d with cos 3x. Then we'll get first term will be cos 3x plus 9 into d. It is d is nothing but differentiation, d of cos 3x. So if we do this step, going to write the final step now, 1 by 730 into cos of 3x plus 9 into, what's the differentiation of cos x? Minus a sin x. What is a value? 3. So minus 3 into 9 is minus 27 sin 3x. This is our YP2. Yes, so one student said that we'll do it separately. Then it is good for you all. Okay, same manner, 2 members posted in the chat box separately. So it is you are able to see what are the difficulties. That means if we do all the things at a time, what are the difficulties we'll do? All the 3 cases we have to think parallelly. What is our YP3? Check it here. Our YP3 is here. We have written 3 by 4 into YP3. So 3 by 4, leave it. So this is only YP3. 1 by d cube plus 1 of cos x. 1 by d cube plus 1 of cos x. That is our YP3. I'm not taking any equation numbers. If you want, you can take it. No problem at all. So 1 by d cube plus 1 of cos x. So now what we have to substitute here? Put d square is equals to, as usual according to procedure, d square equals to minus a square. What is a value? 1. So minus y square is minus 1 square is nothing but minus 1. But we need to, okay, we are having only possibility of d cube, no d square. So d cube is equals to, how much we'll get it? Minus d. For example, we are not having d cube in the problem. If we are having d power 4, then what we have to do? We have to do is here, square on both sides. What is this? D square equals to minus 1. So square on both sides, what we'll get? D square whole square equals to minus 1 whole square. Okay, from this. Then d power 4 is equals to plus 1. Be careful, students. This is plus 1. This is not minus 1 again. Okay, so please be careful whenever you are having d power 4. Okay, now continuation of this is 1 by 1 d cube is nothing but minus d, 1 minus d, and here only I am doing the rationalization also, 1 plus d by 1 plus d, multiply and divide with 1 plus d of cos x instead of by practice you people has to do, these are the direct steps. 1 plus d is the numerator and the denominator will be 1 minus d square of cos x, which is equals to 1 by, what we have to substitute here? We have to substitute d square is equals to, d square equals to how much? Minus 1. Minus 1 square is nothing but minus 1. So if we do this, then better don't write in the same step, write down in the next step. 1 by 1 minus of minus 1 is 1 plus 1 is 2. 1 by 2 into, multiply both the terms in the numerator with cos x. Cos x plus differentiation of cos x is minus sin x. So you have seen how fastly we finished YP3 only because of we are skipping few steps, writing the main steps. Okay, this is YP3. So now what you have to do is substitute YP1, YP2, YP3 in equation number 4. Then you will get equation number 4. But instead of doing that, I'm going to do like this. Substitute. One second. So now substitute equations 3 and 4 in equation number 1. Then what is equation number 1? Y equals to yc plus yp. But what is yp? We have written as yc plus yp1 plus 1 by 4 into yp2 plus yp2 plus 3 by 4 into yp3. Now you are having yp1, yp2, yp3. Substitute all the things here. So what is our yc? Yc is c1 e power minus x plus e power x by 2 or 1 by 2x into c2 cos of root 3 by 2x plus c3 sine of root 3 by 2x. This is only yc plus yp1. What is yp1 we got? yp1 is, anybody can remember, 1 by 65 into cos of 2x minus 1 minus 8 into sine of. So I am substituting yp1 value 1 by 65 into cos of 2x minus 1 minus 8 into sine of 2x minus 1. This is yp1 plus 1 by 4 into yp2 value. So yp2 is, we got here 1 by 730 of 730 into cos 3x minus 27 sine 3x. So 1 by 4 into 730 into cos of 3x minus 27 sine 3x. 27 sine 3x. This is yp2, but yp3 is 3 by 4 into 3 by 4 into yp3. yp3 is 1 by 2. So 3 by 8 into plus 3 by 4 into 1 by 2 is there. I am writing 3 by 8 into cos x minus sin x. This is the small solution of our problem. Y is equals to. So what is the solution? This everything is the solution. How small the solution is. Okay. So E is a general solution of given DE. Don't assume that this much of lengthy question you will get it. Okay. I mixed. Actual problem is only this is the part, cos of 2x minus 1, but still I added cos cube x term. Only one term added, this much of lengthy our problem. So 99.9999% you are not going to get this much of toughest cases. Okay, so only 1 or 2 terms will get it, that too in the form of simple cases.